I'm starting to stream. I'm glad I didn't start before I started because it was a bit of a shambles here a second ago.
Oh, play.
Boom.
Well, tonight I thought we'd have a look at frame of reference. No, there's no underlying question or debunking or whatever they call it of it, but it's I suppose
Explanations.
well, it's observations in general. So I know there is some people out there that do have problems with understanding observations. So we might be able to go through this together ourselves and just see what things are and how things work in frames of reference.
Wonderful.
So nobody's got any questions about it in the first place, even by the sound of it.
It's because we understand what we're about to explain.
Yeah, but not everybody. There are some people out there that don't understand what a frame is and what a reference is.
Oh dear.
When you refer to something and you try to frame it, they don't understand your reference.
My house
Yeah.
frame's made of hardwood.
See, there you go.
I've got a frame of hardwood.
Yeah, they can't think of the other observer. That's their problem. So to you, it looks like it's doing one thing, but to the other person, it's doing something completely different.
So you're saying that two people can be observing the same thing and see something different?
Yep,
Absolutely.
that's frame of reference.
Even if you were standing next to each other virtually.
Well, okay, here's the thing. Say you got three people. You got two people throwing a ball to and fro from each other, and the other person is standing in the middle of that. Okay? To you, it looks like the ball is going straight to that person, but the other person will see a slight arc in that ball. That's the change of the reference frame.
Well, the classic frame of reference observation is sitting on a train at a platform, and you're looking out the window and there's another train right beside you. And you look out the window and you think you're moving because you're going past the other train. But then you see the tail end of the other train go past your window and you realise that it wasn't you moving at all. It was actually the other train.
Yeah, that I've seen that a lot up in Sydney when you because all the trains run parallel on the tracks, and you might be just cruising along quite smoothly, not realising that you're actually moving, because once you accelerate it to the speed and you're constant, you don't realise you're accelerating anymore. And then you see the train go past you, and you think, that train, we moving or is it that train moving?
Yeah, am I standing still, or is it that we are moving slower than that train, or what's going on?
Well, there's a little short thing that I can't play. It only goes for 8 seconds, so I think we can get away with it. But I'll have to watch. We'll have to watch it and see what we make of it to start with. As a, I'll share that. Be able to see that. Everyone see that? We've got a bit. I don't think we need volume, but
Well, it's on the YouTube, buddy.
here we go.
That'll do.
Whee!
That'll do, Terry.
He was going straight up and down.
Yeah.
But yet the tractor's going forward.
Well, it depends on whose frame of reference you're looking at from, whether he's going straight up and down, isn't it? I mean, if you're at the side looking solely at the person compared to the background that you're standing on, he's not actually going straight up and down. He's moving in parabolas.
Yeah.
Almost like a sinusoidal wave, in fact.
Yeah, that's why the camera is moving with it, to give you that reference frame, though.
Yes, yeah, we're travelling with it, yeah.
Yeah, so if you're actually now looking at it from a point of view of one of those people standing on the trailer, yeah, he's going straight up and down because that frame of reference is moving relative to the external frame of reference, the ground. And if you're on that frame of reference, then he appears to be just going straight up and down.
Yeah, and what gravity's trying to explain is when he goes up, because he is moving with the velocity of the trailer, to the outside reference, if you weren't moving with it, it would look like he's doing an arc, even though he is technically just going straight up and down. It's because he's got horizontal movement as well as vertical.
Yeah, well, when you say technically he's going straight up and down, once again, you need to specify which frame of reference you're talking about when you make that statement. So from the point of view of a person standing in the frame of reference of the trailer, yes, he's going straight up and down. But from the point of view or the frame of reference of someone standing on the ground, he's not going straight up and down.
But he is landing in the same spot on the trampoline.
Yeah, but in the external frame of reference from the ground, he's not landing in the same spot because that spot is shifting.
Oh, you're getting shifty on me, Gravity.
Yeah.
So if you took the trampoline away and the truck away and just imagined him going up and down, he'd be touching points of the road in a forward
In different spots.
Spots on the road every now and again when he comes down on touches the trampoline. Yeah.
Yeah, it'd be like bouncing a super ball, like throwing a super ball down at an angle and watching it bounce along the road.
But yes, as Gravity pointed out, the people that are on that trailer, he's just going up and down.
Yep.
How about we get a guy that's from the in the black and white era try to explain this? Then we
Hey,
might
that's
get
racist.
Well, I've got something a bit more modern that's a bit more cartoony. It hasn't got actually anything realistic in it, but it's got some
But
drawings.
it's CGI. Come on.
Well, we could probably watch that first and then go backwards. That might be interesting. We'll see if he explains it.
Right now, we understand that physics is concerned with the motion of objects and the quantitative analysis of that motion. But this can be tricky business if you really think about the fact that everything is in constant motion. When we say that a car is moving at 100 kilometers per hour on the freeway, we are ignoring the fact that the surface of the Earth is rotating around the center at about 1,700 kilometers per hour at the equator. Earth is also moving around the Sun at around 30 kilometers per second. The entire solar system moves around the galactic center at 20 kilometers per second, and the Milky Way galaxy is moving through the universe at about 230 kilometers a second. So it's not completely wrong to say that the car is actually moving with this incredible speed as well, meaning that in a certain context, there's practically no difference between flying in a plane and sitting still in terms of absolute velocity.
Well, I was going to pick up on that bit. Go back. Person and the plane are moving through the universe at roughly the same speed. In comparison to speed, there's not that much difference, is there? If you wouldn't want to say it's exactly the same speeds.
Yeah, I mean the thing is, Imagine you had some magic kind of aeroplane that could fly around the world non-stop forever, and you had people living on this aeroplane, and they lived their entire lives on this aeroplane, and they bred and had children, and the children were raised on the aeroplane, etc. Now, if that aeroplane was moving around with a constant velocity, and it was really smooth, the people that were born on that aeroplane and raised on that aeroplane would know nothing different if they wouldn't realize that they were the ones moving. If they had no windows or anything, they wouldn't realize that they were the ones moving around the earth, because they've got no other frame of reference to observe, nothing to observe that tells them that they're moving. All the experiments that they would do would confirm that they're stationary, that they're not moving. Only when they accelerate in some way, it's only when you're in an accelerating frame of reference that your experiments will come out different. You'll get different results.
Absolute velocity. But that's why we tend to discuss relative motion. We don't notice the movement of the Earth and the Sun and the galaxy in our everyday lives. To us, the Earth seems to sit still, and a few dozen kilometers an hour may be insignificant in the grand scheme of the universe, but it's a big deal to the cop with a radar gun ready to pull you over. So we often discuss motion that is relative to the surface of the Earth. When we do this, we are assigning something called an inertial reference frame. This is the object or person or location that we pretend is completely still, and we assess the motion of other objects relative to this inertial reference frame. For example, if we treat the Earth as an inertial reference frame and we ignore its rotation and movement through space, it becomes meaningful to say that...
At least they're using kilometres an hour here. That's helpful.
Yeah, real.
Oh, but it's stationary Earth. Oh my God, stationary.
So we're going to say the car's moving 100 kilometres an hour plus the 1700 kilometres an hour of the Earth spinning?
That this car is moving directly north at 100 kilometers per hour relative to the ground. But if we are inside the car moving with constant velocity, it seems as though we are not moving, but rather that the surroundings are rushing past us at 100 kilometers per hour. The car has become the inertial reference frame that is standing still, and everything is in motion around us. It may seem strange to pretend that the car isn't moving, but remember, it's just as incorrect to pretend that the Earth isn't moving. So it really is all relative. Imagine you are sitting in a moving train. You toss a ball into the air and catch it. To you, the ball went straight up and down. But to an observer on the ground, the ball followed a parabolic path as the train went past. This is because when the ball leaves your hand, it still has all of the forward velocity that the train does. But if you are inside the inertial reference frame of the train is not moving at all. It is the surroundings that are moving. So the ball no longer has any horizontal velocity, only the vertical velocity you impart to it by moving your arm to throw the ball. Assigning frame...
That we'll just discussing that as in similar to the trampoline then, aren't we?
It's exactly the same.
And it doesn't matter how the ball is made to go up and down, whether you're bouncing on a trampoline or throwing the ball up and down.
Yep, and all of that is true and correct, providing that reference frame or that train is moving with constant velocity. As soon as it starts to accelerate, you observe different things happening to the ball. It starts to behave in a way that's not consistent with an inertial frame of reference.
Yeah, with acceleration, it might seem to go backwards instead of forwards.
Yeah,
and deceleration, I gather. Yeah.
Well, deceleration, what you say is just negative acceleration.
So your deceleration would make it look like the ball went further forward, whereas with the acceleration, it make it it looks like, okay, not that it does, it just looks like it. And that's the problem with inertial reference framing.
But if you threw the ball up just as the train or the train moved forward, wouldn't the ball go backwards at all?
Yeah, I mean, if you threw the ball up in the air while the train was accelerating, as in getting faster, then the ball would not go straight up and back down into your hand, because as soon as that ball leaves your hand, you're no longer putting any force on it to carry it horizontally. All right, so there's no force acting on it to make the ball speed up at the same time as the train's speeding up, and so the ball would fall behind. It's only while the ball's actually in your hand that you're going to be exerting a force on it along with the train to accelerate it with the train. But as soon as it leaves your hand, that force is no longer there. And so the ball will fall behind if the train is accelerating. That's how you can actually tell if you're in an inertial reference frame or in an accelerating reference frame. You do experiments and you find fictitious forces happening, then you know that you're not in an inertial reference frame.
I did want to find some sort of depiction of how on a roundabout, if you were in the centre and you threw a ball outward. That I know it's a similar to do with the frame of reference, but it's also to do with something spinning and then you throw it outward while it's at a constant velocity. I was going to see if I could find a video for that, but I couldn't find one.
Give me a second, Terry.
So thanks, Secretary. I'll play this for a little bit longer then again.
Frames of reference and understanding what they mean for the motion of objects is a big part of physics. And although some aspects of this kind of thinking seem obvious, they were not always well understood. Galileo was the first to rigorously describe relative motion after doing experiments in a moving ship. He found that if he dropped a ball while the ship was moving with constant velocity, it fell straight down, just like it did when the ship was stationary in the port. He then contemplated how a fish nearby would view the motion, with the ball moving forward as it falls, and how this differs from his own experience.
I didn't know fish were that intellectually curious, wanting to know what they see. They must be smart fish. You'll probably forget it 5 seconds later, and the boat will have to go past again.
He used these experiments to prove that velocity measurements depend on which reference frame you adopt. And he published his findings in a book called Dialogues Concerning the Two Chief World Systems in 1632.
Well, we'll have to get that book out and read it. It's a bit of light reading.
Ideas were extended to describe the motion of the Earth around the Sun instead of the other way around, by proving that the Earth could be moving even if we don't feel it. This got Galileo and other scientists into hot water with the Catholic Church. But humanity eventually caught up to his revolutionary thinking.
Oh, is this another one of those scientific premises or theories that the Church didn't like again?
It was heresy.
They didn't seem to like anything to do with science, did they?
Yeah, it was all heresy
Well,
when
not
they
the
did
Catholics.
these tricks.
We refer to this portion of his work as Galilean relativity, and these concepts will be built upon to enter very strange territory when we cover Einstein's special relativity in the modern physics course. But for right now, we won't go flying through space. We have much more work to do on Earth, which, despite its rotation and motion, is actually quite a good approximation of an inertial reference frame, one that will be used frequently throughout our study of physics. With each topic we go through, Whenever we examine an object's velocity, just remember, it's all relative. Thanks for watching, guys. Subscribe to my channel for more tutorials.
Yeah.
You made your explanation. Now piss off.
It reminds me of Earl off My Name is Earl.
I'm just imagining the goldfishes like certain people we know. Explain it to them 1 minute, or they try to show them the observation, and then 5 minutes later they'll come out with something else that's, well, weren't you listening 5 minutes ago when I just explained it to you? In
Hello.
huh?
Hello.
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 Hello. Yeah,
Hello.
I know the pause was me taking a drag of a cigarette. Sorry, I can't talk while I'm breathing.
Okay, there's 8 of us on screen, and only 3 or 4 of us have been saying anything. Have they all gone to sleep?
I've been Google fooing and sending out messages.
I've been shoving my face full of pizza.
How dare you?
There's a link to a roundabout experiment in the side chat there, Terry.
And I'm getting ready to go out.
Yeah.
To an observer above the Mary.
Rosie and Nathan are getting ready to go to a wedding. I wish they'd hurry up. It's so stressful. I can hate to think what it's going to be like with on the day. They do it.
So did you understand what he meant by Galilean relativity?
No.
Okay.
That's why I'm watching these videos to see if I can understand any of it.
Yeah. Galilean relativity is just where your frame of references, to calculate the velocity in one frame of reference as compared to the other, you can just add or subtract the velocities. For instance, let's treat the Earth as a stationary reference frame, right? And you throw a ball forwards at 10 kilometres an hour. Now, what if you're standing on a truck moving at 100 kilometres an hour and you throw that ball forwards at 10 kilometres an hour in the same direction that the truck is travelling? How fast is that ball going relative to the ground? Terry?
Relative to
hear
the ground.
Yeah?
Fast.
So if the truck's moving at 100 and you throw the ball forwards at 10 kilometres an hour, how fast is that ball going relative to the ground?
So on the premise that
it should be 110 if your reference frame's that looking at the truck, if you're stationary on the side looking at it going past you or something.
Yeah, that's right. That's exactly right, Terry. And so what you've used just then is Galilean relativity. So what you've done is you've just added the 10 kilometres per hour of you throwing the ball to the 100 kilometres an hour that the truck's moving at to get a ground speed of 110 kilometres an hour. And that's what Galilean relativity is, where you add or subtract those velocities like that. When it comes to
so I was the goldfish in the boat experiment.
Yeah. But when it comes to special relativity, you can't do that. You can't just add or subtract the velocities like that. It's a lot more complicated than that.
I wonder if the roundabout one's going to be throwing us off track for now if we watch that one.
No, I think it's.
Or is that a different type of?
No, it's the one.
Well, that's to do with this is the Coriolis Force.
Yeah, it's still reference frames. It's just a little bit. It's just a little bit more twisted. It's just a little harder to understand because who's got the dog woofing?
It's like you standing outside our galaxy and watching it turn, but you're also inside the galaxy.
How can I be in two places at the same time?
There you go. It's all about frame of reference. special relativity and relativity.
See, when you're on the train, and we've talked about throwing the ball in the air, and if the train's moving at a constant velocity, the ball will just go straight up and down from your point of view inside the train. But if the train's accelerating while you throw the ball up and down, then we sort of came to the conclusion that the ball would fall behind. It would appear to go behind. That's because the train is accelerating. Well, if you're on a body that's rotating, if you're standing on a body that's rotating, you are actually accelerating as you're going around on that rotating body. And so we'd expect to see some kind of thing happen when we throw a ball in the air, or when we throw a ball. We would expect to see something unusual happen to that ball because we are accelerating. And we do indeed see that. That's what we call the Coriolis Force. There are two other forces that come along with that too, but the Coriolis is the one that most people need to take into account.
On the roundabout, wouldn't there be three frames of reference? One from the observer outside the on the Earth, on the ground, the person on the roundabout, and the ball's frame of reference.
Yeah, you can invent as many frames. Who's got the dog? That's annoying. You can invent as many frames of reference as you like.
That's Pip.
Maybe use push to
I'll
talk.
fix her.
Yeah. You can have as many frames of reference as you like. You basically just pick an object or pick somewhere to stand and look at all the motions from that point of view. So you're right, Terry. You could either look at it from the point of view of someone sitting on the roundabout, or from someone standing at the side of the roundabout, or from a point of view of someone on the ball itself that's moving. Yeah, you're right. Then you could have a frame of reference of someone standing outside the Earth watching the whole lot spin around and the merry-go rotate around as well. And then the motion gets really complicated when you look at it from that frame of reference.
Sean says, why does it always have to be a ball?
Yeah, that's right.
All right, throw a freaking pineapple
Yeah.
so it doesn't belong on a pizza.
Well, you could make the merry-go-round interesting by throwing darts at each other or something.
No.
Well, you could.
You could.
You could,
It'd
but
be
no.
interesting.
I'd be more worried being the person outside the reference frame than the people in the reference frame.
That'd be a good experiment. If you tried to stand on the roundabout and you had a dart and somebody was outside the reference frame on the ground with a dartboard, and you tried to throw that dart at the dartboard while you're going around?
Well, it would be interesting having a game of darts with, say you put a dartboard up on one side of the merry-go-round and you're standing at the other side of the merry-go-round while it's rotating. That would be an interesting game of darts.
Yes, it would be. I'd rather be the thrower than the throwee. Oh, we'll have a look. This one goes for...
The safest place to stand would be in front of the dartboard, I reckon.
Yeah, you would. Yeah, you're not going to hit the dartboard. Why?
No, that's
right.
right.
Throw it. We'll find out.
Path of least contact.
Yeah.
Well, it only goes for 20 seconds, so we'll just let it
To an
play.
observer above the merry-go-round, the path of the ball appears straight, while to someone sitting on it, the ball appears to curve to the left.
You're not cheering.
This exemplifies the Coriolis Force.
Oh, sorry, I got distracted with talking about darts. But I see your point. Oh, that was meant to be funny, but don't worry about it. Play again. We right now? We happy, Vegemites?
Yes.
To an observer above the merry-go-round, the path of the ball appears straight, while to someone sitting on it, the ball appears to curve to the left. This exemplifies the Coriolis Force, whereby, to an observer on the rotating Earth, the path of an object appears to be deflected, and this is a result of the Earth's rotation.
That would confuse flat earthers to no end.
To
I have to turn the volume down. I'm trying to wrap my head around this one. Yeah, this shot there. So when they were throwing it, which way was it? I'll try to get it mid-flight. So when the guy in the yellow shirt threw it, it went to his. Which way was the merry-go-round going around? Clockwise. Okay. And the ball left his hand, but it went that way. I'm going to have to think about that.
Surface is moving underneath the ball, Terry.
Oh, the surface is moving underneath the ball. So
Yeah.
the thought just came to me in mind. I heard it in my head.
Whereas if we did it on Earth, we got the atmosphere.
Hey.
Don't worry about it.
Okay.
Continue.
Oh, that's it. That was the rest of that. I was just trying to figure out why it was going to the left. Because I'm imagining if you were throwing when you threw it. Because I've seen a video or somebody explain it where you threw something off a roundabout while it was in motion, and it gave the same arc effect. Because the ball's still trying to travel in the direction that you threw it, but because the roundabout's rotating.
Yeah, but see, that's a very short distance. Remember, if you shot something north-south over like 30, 40 kilometers, like a gun, a huge battleship
like artillery.
An artillery gun, exactly.
Because that's the problem. You have to have it going over a very long distance in order for it to have a significant effect.
See, what's happening there, Terry, is that you're not looking at the scale. That's a very tiny scale, and it's a very large force that's been exerted there underneath the ball.
Because it's a very high rate of rotation.
If the Earth was traveling scaled up, if the Earth was traveling the same speed as that merry-go-round, we'd probably be flung off.
We've been told that we could fly off because we're doing over 1,000 miles an hour. Why aren't we flying off into space?
It's all about scale. So
if you kept the same, it's with Coriolis, it's all about angular velocity. And although it relates to the changes in linear velocity as you move across, that's all defined by the angular velocity.
If you slowed that merry-go down, if you slowed down the merry-go-round to one rotation every 24 hours and did that experiment, you probably wouldn't see that effect.
Like on Earth.
Yeah, I mean, you've seen the radar systems that I work on, and some of them actually had rotating cabins that you could stand in, and they rotated at 4 RPM, and in about the 20 feet across that they are, and I've seen this demonstrated. If people threw something to each other, and they threw it straight at them, they would miss by about 4 feet in front of the direction of rotation.
Yeah, to get the same centrifugal force as what you experience on the Earth, spinning Earth at the equator, if you had a 10-metre diameter roundabout, I haven't done the calculation for a while, but I think it turns out to be one rotation every about 72 minutes. It'd be pretty boring merry-go-round.
Yeah, you wouldn't get your money's worth out of it.
No, you wouldn't. And I'd challenge anybody to feel that. If they were sitting and it was a really smooth merry-go-round, I would challenge anybody to feel themselves sitting on a merry-go-round, 5 meters radius that rotated once every hour and 12 minutes.
Yeah. They did the similar with the Sagnac experiment with light bouncing off mirrors.
Yep.
to the observer standing outside, it looks like light is slowing down, but it's really the mirror that's moved. But if you're actually in the experiment, light is still traveling at the same speed.
Yeah.
Where am I?
Next.
Next. I suppose this one's back to the similar thing of the ball. Ball moving from a cart. So
if you're interested, Terry, I don't know if Gravity wants to interject here. I've actually found a 2-minute video explaining the Einstein theory of frame of reference, so the Einstein theory of relativity. So it goes over his thought experiment with the train and 2 lightning strikes.
You're talking about special relativity, not general relativity there.
Yeah,
but you don't want to confuse me yet.
It's 2 minutes, and it's really going over the whole. Although it is touching on the speed of light and stuff, it's more about the frame of reference and how.
I think it'd be wise to
wait.
do a little bit more on just Galilean relativity first. Yeah.
Okay, I'll have to remember that terminology. Galilean relativity is basically what we've been doing so far with the train and the ship and
with just adding and subtracting velocities and stuff like that.
Okay.
It's very intuitive. It's how you think it should work.
Yeah.
Works very well for the velocities and masses that we are used to dealing with.
Yeah.
Which is why it hung around for so long. I mean, it took from the 1600s right through to now, because we still use Galilean relativity an awful lot, because mostly we're not trying to go near the speed of light, and mostly we're not going near quasars and black holes or stars. Or trying to do really, really accurate timing of stuff.
So what do you got for us, Terry?
That's it's in black and white, which I'm sorry, I can't help that.
That's right. You'll understand it then, Terry.
Yeah. I don't need colour. Colour throws me out, throws me off. Oh, look at the pretty colours. Oh, what are we talking about?
You feel at home with the technology of your day, hey?
Well, to Quasar, this is probably okay. Quasar's older than me, Elmo.
I don't like that trade sequencing.
If this was cave paintings, Quasar, I'd understand it.
Oh, now settle.
This steel ball can be held up.
What? Sorry. I keep forgetting you're involved in this too. Yeah, go again.
This steel ball can be held up by the electromagnet. Now I'm going to open the switch, and you watch the motion of the ball. The ball is accelerated straight down by gravity along a line parallel to this vertical reference line.
You want to be careful there, Waller.
As you can see, the electromagnet is mounted on a cart that can move.
Sounds like you're doing something else.
I'm going to do exactly the same experiment that Dr. Hume did, but this time, while the cart is moving at a constant velocity. The cart is pulled along by a string which is wound around this phonograph turntable, and that pulls it with a constant velocity. When the cart passes this line, the ball is released, as you can see. I'm going to start the cart down at the end of the table so that by the time it gets to this point, I can be sure it's moving with a constant velocity. Now, I want you to watch right here so that you will see the ball falling.
All I seen was the ball fall.
Yes.
Hmm.
You should have
But in what direction?
Ah, okay.
forward.
Well, the trolley was moving forward.
Yes, and the ball continued to move with it.
And yet it took exactly the same time to go from the release point to the trolley as it did when it was standing still.
But it travelled further.
Hmm.
Well, the ball didn't travel any further. It's the same.
Well, in the point of reference of not on the trolley cart, it did.
Ah, so there would be an arc line from that line back on the table at the top point to where it is resting now. If we could draw an imaginary line, it would arc downwards.
Yeah,
it
almost.
It moves forwards because in the outside reference frame, it's already got some movement, and S equals UT plus a half AT squared. Sorry, I've never been able to get that equation out of my head.
Inertia, Alan.
Sorry?
It had inertia. That's what you have to say.
Yes, of course it does.
Yeah.
And if you added up all of the stuff, made the you could use the equation to find the distance. You would use the equation I just gave, and since it has since u is non-zero, it will have to go further than if than when u is 0, but only in the outside reference frame. On the trolley, u is still 0.
But I'm right in saying from our reference frame looking directly at it, when the ball's at the top of its travel to where it lands at the bottom of its travel, from where the line is on the table where it first dropped,
yeah,
you could imagine that there's a line arcing downward to the bottom of where the ball is now.
Yeah.
The ball didn't actually do that, Terry.
No, the ball didn't actually do it, but it's our visual reference of what we would see.
Because you've got two systems that are moving where the relativity comes in.
I think you can see that the ball landed in exactly the same position that it did before, when Dr. Hume did the experiment with the cart fixed. But this time, the ball could not have fallen straight down. Let me show you why. The ball was released at that point. If it had fallen straight down, because the cart moves on in the time that it takes to fall, it would have landed back here somewhere. But it didn't. Now I'm going to do the experiment again. And this time, I'm going to let you watch the motion through a slow motion camera, which is fixed here. As the cart moves by, the ball will fall, and you can watch in the slow motion camera.
Hang on, just before he does that, just a quick one. Did you notice that as he pushed that through and stopped it, the ball then landed in front of the post?
Yes, it did.
Inertia.
Yeah, the ball had
because he made
in it.
Because the ball had velocity, and he changed the velocity of the truck after. Yeah, in the next little bit where he shows it, where he pushes it past the camera before it starts, you will notice that the ball tends to move forward still as he stops the little truck there.
Yep.
And we can actually see it go forwards because he's nicely dark for the ball to be nicely light against for us to see it as it moves.
He also dropped it back further too.
Well,
Not there.
it dropped wherever the line is because the line is there. There is a.
Stop it, Terry.
What?
Let's just go back to.
Backwards and forwards, backwards and forwards.
Yeah, because the trolley didn't accelerate there, so although it would have moved forwards as we discussed, it oh bugger! I wish I didn't keep going blank like that. I'm sure when we see the slow motion, we will see exactly the motion we were discussing, but it was just that one where you get to see the ball land just in front of the post because there was some acceleration of the trolley.
I'll show you this again. This time there will be a line on the film so that you can see the path. I think that you can see that the path of the ball is a parabola.
I was thinking that there was going to be the other way.
Why?
I mean, the curve would be the other way. I was saying the curve was the other way, wasn't I?
If the ball didn't have velocity.
No, I think what Terry is thinking is that the ball would drop. Remember, when you first release the ball, it has sideways. It has what will be a constant sideways velocity.
Right.
But it hasn't got any vertical velocity yet because it hasn't had any time to accelerate because t equals 0.
Okay.
And in the first, in the first second, I know it doesn't last a second, but in the first second it would fall 9.8 meters, and then in the second it would fall 19.6 meters. Yeah.
Mm-hmm.
And in the third second it would fall 3 times 9.8. Sorry, I'm not doing that in my head. So of course the downwards velocity is getting faster and faster and faster all the time. So you will start off with it having a very no to very small degree of vertical displacement from.
If the ball did not have any inertia and he was holding it and he dropped it as the stick went past, the ball would have dropped straight down. But because the ball had inertia, when it fell, it has that velocity of sideways motion. Then gravity will take over, and that's where they get the parabola from. Is that better explained, Terry?
A little bit, yeah.
Because the sideways speed is always the same.
Yeah, I understand.
But it's getting faster downwards.
Yeah, that's why I went back to the beginning of that. That's why I slowed it down a bit so I could actually see it.
See, the ball's got movement, Terry?
Yeah, it's moving laterally.
Let it play. See how the ball's got sideways movement? It's moving with the experiment, and then it drops.
Yeah, lateral.
So it still has inertia from it moving sideways.
So that's the release point there.
Yeah.
So the ball's still got enough inertia to keep moving it laterally, which is sideways, forward.
Yeah, sideways, sorry. Yeah.
Yeah. I call it lateral.
Yeah. And it'll keep moving, and it'll keep moving in that direction at that speed throughout the experiment because the air resistance is negligible.
Yeah. Even in a vacuum with this would still be similar.
This would work it would work exactly the same in a vacuum.
Yeah.
You probably wouldn't notice any difference. It would not be measurably different. using the measuring tools you're likely to use.
So I was totally wrong about the arc effect. I should have waited till it finished, but I was just guessing.
No, that's how you learn.
Yeah.
Yeah,
I knew there'd be an arc. I knew there'd be an arc effect because as it went down, it's okay. Now I can see where I.
Well, it all had solid motion. If it didn't have any solid motion, it would just drop straight down and behind the stick. If he held the ball and pushed the stick past it, and then as the stick went past his hand, and he dropped the ball at the same time, because the ball only has downward motion, no forward motion, no inertia, the ball would have gone straight down and landed behind the stick. There would be no problem. But because it had inertia from it being moved and then dropped, it's like you throwing a ball or Newton's cannon.
I'm trying to think of it as in if that table was the Earth.
Yeah.
And then something was we're on the table watching it fall.
Well, you've also got the atmosphere, which is being dragged along with the Earth.
That gets really interesting, Terry, your point of view now, because once you start talking about standing on the Earth, looking at things rotating, I mean, think of a really tall building like the Empire State Building or something like that. Okay.
How would planes get anywhere, Terry?
Yeah, but think of the Empire State Building, right? And the Earth rotating. I mean, the top of the building rotates around once a day, just like the bottom of the building does, right? But because the top of the building's further away from the centre of the Earth, it has to actually travel further to do one rotation than the bottom of the building. So the top of the building's actually moving with a greater linear velocity than the bottom of the building. So if you were to drop a ball from the Empire State Building, and if you would totally ignore air resistance,
or drop it down an elevator shaft.
Yeah. So if you were to do that, then the ball at the top of the building, right, keeps its horizontal velocity, and so as it drops, it will actually move sideways a bit because it maintains that horizontal velocity.
Yep.
The velocity of the bottom of the building is less than the velocity of the ball, and so the ball will move ahead of the building as it falls. So it won't drop immediately below where you drop it from. It will actually move slightly. This is one of the experiments that you can do to prove, or to not prove, but give you more evidence that the Earth is actually rotating.
Well, anywhere where there's a really, really tall building, let us do that.
Yeah.
Drop it down an elevator.
And gravity, with that, obviously there would be a difference, obviously, if you dropped it, say, from the west side of the building compared to the east side as well, wouldn't there?
Well, from one side, it's going to hit the building as you drop it.
Yes.
That's the only difference. The other, the reverse effect also happens too, that if you were at the bottom and you shot something upwards, it's actually going to lag behind.
Yep.
Because the velocity is not as great as needed to go around once a day up higher. So it will actually lag behind as you shoot it up.
Do that in reverse, Terry.
Yeah.
Do that in reverse.
Do what in reverse?
You just played.
I can't
While
play
the
it
ball
in
going
reverse.
back up, the ball going. Yeah, you can. Just move the slide bar a little bit backwards. You'll see the ball go back up to meet the top. So it's taken us sideways.
No, you can't do that.
It's quite difficult in the.
You have to get it pretty huge to do it.
Oh,
so.
by the way, the dropping something down off the thing was done in a vacuum by Tom Scott in the big tall vacuum tower in Germany.
Yeah.
And it moved offline by exactly the amount that was calculated up front.
Does anyone know what effect that's called?
That one's the Votos effect, is it?
No, that is actually the Coriolis effect still. Right? People think
Yeah,
people think that the Coriolis force only acts when you shoot things north-south. That's not true.
I was actually trying to think of what's the reverse of the Coriolis.
Yeah, no, it's actually the Coriolis.
Yeah,
I mean,
I
people
thought
say
they'd given.
People say
I knew
there's
it was all Coriolis.
Yeah, people say there's no Coriolis force on the equator. Well, that's not true. If you're standing on the equator and wish to shoot something vertically upwards or drop something vertically downwards, the Coriolis force does apply there. Yeah.
So you'd actually, on that premise, if you got on a tall building and dropped a ball, like you said before, at the equator, because the speed there relative to
the bottom of the building,
the bottom of the building would actually be even higher. Again, you'd get more effect. Yeah.
Yes.
Yeah.
Yeah.
Now, this brings me up to another with the atmosphere. You're saying about in the room, because the atmosphere is not really is negligible for the effect. But what about when they used to drop the bombs in World War II, when the spotter used to be going across the target, and then they'd say, "Okay, drop it now." That means he'd have to be in a certain position above the target for the bomb to land on the target, but also have to allow for wind resistance or something as well, wouldn't they?
Yeah, he'd certainly have to allow for air resistance there, because I mean the air resistance varies, with the square of the velocity. So it gets pretty big pretty quickly as your velocity increases. So when you're traveling at the speed of an aeroplane and you drop something out of that aeroplane, you're going to be like hitting it with 100-mile-an-hour wind or whatever. So it's certainly going to affect the projectile in that sense, yes.
If you look, that's one of the reasons. I mean, the American Norden bomb site basically had a mechanical computer in it that was able to compute quite a lot of the aircraft's movements in relation to the Earth, because it had things like gyroscopes in it. And that was one of the reasons why the Americans were so insistent on daytime bombing, because you needed to be able to clearly see the target to use the Norden bomb site to get accurate hits. The RAF also had a different but similar bomb site that also had the mechanical computing built in that allowed errors of aiming of under 100 feet from 20,000. For hitting a target with a circular area of probability of a diameter of 100 feet from 20,000 feet. And when you're dropping those bombs from that height, you're dropping them from about 10 miles. You're about 10 miles away from the target when you actually release the bomb.
And is the bomb still going to have any forward momentum, even though it's got air resistance
Can you see the parabola that thing made, that ball made?
Yeah, we're looking at it now.
That would pretty much be the parabola you would see with the bomb. Now, because, as Gravity said, the wind resistance effects are square of the velocity, it will be slowed. It will give up some of that forward velocity to wind resistance, especially as the bomb becomes more and more nose down, because obviously it is aerodynamically shaped, and the RAF ended up dropping bombs that had a massive, that weighed 22,000 pounds, and they dropped them from altitudes of 18 to 20,000 feet. the bombs would actually go supersonic on their way down. But they would in general follow a parabola that is very close to the one we see on screen at the moment.
Right. Because that's what was reminding me of it when I seen that. I'm thinking if that was an airplane dropping a bomb out, and the plane's flying forward, yeah, how much of it would it go forward, and how much of it would the bomb go straight down? Yeah.
Most of the bomb retains most of its forward velocity all the way down. That's why they tend to be this. That's one of the reasons they tend to be the shape they are. They're designed to reduce the amount of energy they give up to the air as they fall.
The side chat are talking about shotguns or musket rifles or something. They're still talking about what we're talking about, but I was just reading what.
Yeah, I mean, Terry, can you imagine a semi-trailer, travelling at 100 kilometres an hour, and you just turn off the engine but don't put your foot on the brakes? I mean, how long would it take to slow down?
Depending on wind resistance as well as rolling distance and how level the ground was.
Well, assume that the ground is level and that your rolling resistance is not too great. It's mostly wind resistance, isn't it? But I think you'd agree that it would take a fair distance for it to come to a stop.
Yeah.
You have weight as well.
Yeah, the mass of the vehicle and all that, yeah.
Yeah, that's right, yeah.
Did you get my internal chat thing, Peter?
I do now. Just give me a moment.
Were you on your coffee break, Secretary?
No, I was making sure the bottom cupboard was empty. Actually,
I thought you might have been talking to that person over at the water cooler, and I might have got jealous.
Did you see what I poked you with, Terry?
But where did you give it to me?
In Zoom chat.
Far back up where you. Wrote a message, but didn't post anything.
Yeah, you muted Pip, remember?
Yeah.
Yeah. Well, she wrote that she couldn't unmute herself.
I think there might be a. Did you actually save it? Because I think you might have to save it occasionally. There's some bits you have to save and some bits you don't, and it can get really confusing.
Or restart Zoom. Might have only taken the effect then.
I ticked the box
for me on the phone, it took me coming out. It took me dropping out and coming back in to get the audio to work. But I was okay when I came in on the PC when I fired the PC up. Although I'm pretty sure Pip had to leave because she has to go to closing day at the Bowls Club.
Yeah, she said she was only going to be here till about 10, 15 minutes ago. She had to leave.
Yeah, I think that's about when she did. So yeah, it was. It wasn't because. Yeah, she said goodbye, but it wasn't because.
She could unmute.
I don't think she left because she couldn't unmute. I think she left because she had to go out.
Yeah, she said she had to go out.
Go out to the Bowls Club and drink copious amounts of alcohol again.
Well, I thought she wrote because she can unmute herself.
Yeah, probably. Now we're having a proper
Oh, she muted
water
herself.
cooler moment,
I
aren't we?
muted myself to sneeze. Now I can't unmute. Yeah, but then I ticked it after that.
Did you? Okay.
Yeah.
Yeah, but I think
and then the
but I
dog
think
barked
for
and then
those
I
who were
muted.
muted, but I think for those who were already muted, Zoom didn't necessarily honour the change of allow people to unmute themselves. Because at one point you actually sent me a please unmute message, and I hit unmute, and it says you can't unmute because the person who's in charge has said you can't unmute. That's the point where I left and came back in.
Oh, so I'll have to work out from when if I say mute all now, I've got a box that's ticked allow participants to unmute themselves, and then we tested that earlier. That worked.
Yeah.
Are we turning this into a Zoom tutorial?
I don't know. I got somebody digressed. The granddad went on a tangent.
Old man Quasar.
There you go, Terry.
Where? What did you do?
Well, what you asked for.
Oh, okay.
It's where you wanted it.
Oh, okay.
I was going to say not all of us are granddads yet, you know.
Ooh, I think I am. A couple of
you
times
think?
over.
I thought that would be better than like just a picture of it because it gives
Well,
the
I know
explanation.
you can get footage, real life footage, or black and white stuff, but it's hard to find that stuff.
Yeah, and a lot of it's not necessarily playable.
Yeah. Well, this goes for 8 minutes, so this might be.
Yeah, and it's an educational video, so it's playable.
Okay. And it's got airplanes with propellers, so that'll keep Alan happy.
I like aeroplanes with propellers.
Yeah,
it's not that I don't like jet aeroplanes, but I like aeroplanes with propellers.
Because they go boom.
especially when they've got Rolls-Royce Merlin engines.
You should go listen to the A10 Warthogs, especially when they fire their Gatling gun.
When they go brrp.
I'll go.
Yeah,
I'll go and make me quick coffee while you.
10,000 rounds in about 10-second spurt.
There's a guy that
How close is that mic, Peter?
You behave yourselves while I'm gone, you kids.
It's whenever I move it up and down.
Is that your nose whistles?
My nose whistles.
Yeah.
Sorry, I just thought I might mention it. Let you know. Also with the other thing when you were vaping. It sounded like you were doing something else.
Well, that's your own mind putting that out there.
I know. Who's in charge? Dead air?
Dead air.
No.
Terry didn't host anyone, so...
Continue.
Can you hear me?
Yes.
Yes.
That's just, I'm having problems with my mic.
Yeah, I think something's playing up lately.
Yeah. Hey, Alan, you're talking about the Rolls-Royce Merlin engines. There's a guy that built a bike and put one of them in the bike.
Yeah.
Yeah. People have put them in cars.
There was also a Jag. They put one in a Jag, and it had all the exhaust pipes hanging out the side and going down the sides.
Yeah.
We've got a bloke in our local town that's got one on the back of a trailer, and he starts it up every year at the show.
Wow.
Yeah.
Oh.
Jay Leno's got one, hasn't he? Although his is a Packard built one.
Oh, I'm learning a lot tonight. I never really knew much about bloody the subject, so I'm learning something.
My brother oldest brother. He's a Rolls-Royce jet engineer. He worked for 10 years. He worked on the Concorde and the TriStar. He built this little mini jet engine that he started it up and used to howl. Yeah, well.
Was it just like for demonstration purposes, or did it?
It was part of his. It was an apprenticeship with Rolls-Royce.
Yep.
To scale, it used to do 900 miles an hour.
Oh, gee.
Yeah. And those things, when they get going, they're a really high pitched sound.
Yep.
I've been watching a guy build a jet car, and after a couple of deaths this year, he's giving up on it. He's taking the jet off the back, and he's just going to use it to drag race it because he's got a normal engine in the front. I think he's gotten a bit scared of doing it now.
Well, it's pretty scary.
Yeah.
Tempting fate.
Especially if you build the car yourself from scratch from an old Yank tank, and that. I can't think of what the type. It's the Ute type of American car. I can't think of what they call it. And they turn the back part into put the jet in there, but he's going to take it out now.
I'm back.
Yes, it's tempting fate.
Yeah.
Don't know how many goes you got left.
Are we all right now?
Yeah,
Continue.
I guess so.
Lose anyone? Oh, watch Physics 3.5 3E dropping a bomb, projectile motion. Can you make sure these are posted in homework, please, Peter?
I'm posting everything I give you, and I'm marking the ones that you've played.
Oh, thank you. Let's play.
Talk about the example of a bomb being dropped by an airplane. And over here on the left side, you see the bomb fastened underneath the belly of the airplane, and it's released and it falls downward. What you see in this picture is the airplane shown at 4 different moments in time, and these moments in time are equally spaced. The plane's moving at a constant speed, so the distance it moves in each increment of time is the same. The bomb, though, accelerates down, so the vertical distance that it has fallen after each increment of time gets larger and larger. It gains more and more downward speed. As always, the key to understanding this or solving a problem of this nature is to treat the horizontal and the vertical motion independently. Now, when the plane is flying and carrying a bomb, at the moment the bomb is released, the bomb has the same velocity as the aircraft.
So he's just covering basically the same principles we've already mentioned.
Yes.
So far anyway.
In other words, its initial velocity.
Sometimes it's better to show in pictures, as it's easy to understand.
But this is not 4 different airplanes. It's the same airplane.
It's the same aeroplane in 4 moments in time.
Yeah. Just to clarify that for people that didn't realise.
Okay.
Well, if it's 4 different aeroplanes, Terry, then the person on the ground is going to be hit by 4 bombs.
Well, where's all the other bombs? Ripped off.
Oh, they've already exploded on the ground, see? There's 4 bombs. One's exploded already from the first one.
I don't believe you. Go back.
Oh. You reckon it is or not?
No, go.
Uh,
Continue.
Not a very big explosion from the bomb.
Velocity is not zero, and you see this initial velocity vector drawn in the diagram. The initial velocity is the initial velocity of the plane. In this case, the bomber's flying horizontally. That means the bomb has an initial horizontal velocity. And in this case, it doesn't have any initial vertical velocity. Once it's released, though, it begins to accelerate down due to gravity. But it also continues the
Oh, there's that G word.
forward motion that it had when it was being carried by the plane. So this forward motion of the bomb has to be taken into account by the people doing the bombing, or they're going to miss their target. If they were to wait till the plane were right here over the target and then release the bomb from directly above the target, the forward motion of the plane, which gives the bomb forward motion, that would carry the bomb forward of the target, and it could miss the target by a substantial amount. So the bombardier has to take into account the forward motion of the plane and its height above the ground, and release the bomb a certain horizontal distance before it gets to the target, such that by the time it falls that distance to the ground, it has moved forward that distance and hits the target. And exactly how far in advance of the target the bomb needs to be released is a projectile motion problem. In this example, we're told that a bomber is flying at an...
Okay, example. Suppose a bomber is flying at an altitude of... Oh, we're going to do it in miles an hour. Oh, shit. I hate doing miles an hour. Who knows about miles an hour? An altitude of 1 mile.
They're 1.6. They're 1.609 times bigger than a kilometre.
Oh, we'll work it out.
Is 1.6 kilometres high and 300 times 1.6.
We'll just leave it at miles, and I don't want to do
Yep.
the math. 1 mile.
300 miles an hour. Actually,
miles
300 miles an hour is 450 kilometres. There you go.
There you go.
In fact, for the demonstration, Terry, you could literally just use the word kilometres instead of miles.
Mm-hmm.
But so, I can understand miles. I don't know if anyone else can.
The conversion later, the mile and the kilometre means nothing. So you can be 1 high and have a speed of 300.
Yeah. Okay, so how far ahead of the target must the bomb be released? Now, we haven't been given any other information to go on for that.
What you'd have to do, Terry, is figure out how long it would take the bomb to fall that mile, and then even if it was just dropped vertically at no speed, then you would multiply that time by your 300 miles per hour to get the distance that you need to drop the bomb in front of the target. Basically.
So isn't it? I remember the speed thing, but I can't remember the numbers for how fast something falls.
Well, it changes its speed, doesn't it? It gets faster. It gets faster as it falls. But thankfully, if you ignore air resistance, then there are some physics formulas that are pretty easy to understand that you can use to calculate these things. And he's probably going to go through those calculations now in the video.
Okay.
An altitude of 1 mile and a speed of 300 miles per hour. And this might be typical of a World War II bomber. There were different types of planes that flew at various speeds and all different sorts of altitudes for different bombing runs. But this might be typical for a World War II bomber on a bombing run. And we're asked to find how far ahead of the target must the bomb be released. So here's what we'll do. I'll start by converting things into our standard units, meters and seconds. 1 mile is 1,609 meters. And then the 300 miles per hour, I'll do a unit conversion. I know that there's 1,609 meters in 1 mile. So the miles will cancel out. And I know that 1 hour is 3,600 seconds. So the hours cancel out. And I'm left with meters per second.
No,
and
wait
when
a
I do
minute.
the math here, 300 times 1,609 divided by 3,600.
I thought he was doing it in miles.
He's converting it into standard units, Terry, just for you.
Is 134 meters per second. So that's the initial velocity. Now, to solve this, I treat the horizontal and vertical motion independently. So I'll do the vertical this case. Do the vertical first in this case. I know the vertical distance. It's 1 mile, or this many meters, 1,609 meters. So I can find the time it takes the bomb to fall. The time that it falls depends only on the height. The horizontal speed doesn't affect the time it takes to fall. So vertically, this is what I know. V0, the initial velocity, vertically is 0. The plane's flying horizontally. The acceleration will be 9.8 meters per second squared. This is assuming that down is the positive direction. And then I can say the initial position is 0 and the final position is 1,609 meters. And it might help you to make a little sketch to visualize that. You can draw the bomb here. It's moving along at its initial velocity, and it's moving down like this. We can consider down to be positive, then the height right here is 0 meters, and here it's 1,609 meters. And you should see that the 0 and the 1609 set up like that is consistent with down.
So the 1609 is the distance travelled.
In the downwards direction. Not the distance travelled by the bomb in the arc, but just the distance from the top to the bottom.
Right, okay. And the equation V... Okay, I'm trying to follow the equation as he's...
He hasn't put the equation.
Well, he hasn't put the equation there yet, Terry.
So here's what we'll do now.
And Terry, why am I unspanned?
Yeah, why am I unspanned?
Why? I hear a revolt happening.
Why am I unspanned?
A revolution.
There's going to be a revolution. Oh no. Oh shit. Everyone's getting at me for something. There.
It's hard at the top of it, Terry.
Uh-oh, Rich the Black's unspanned. Have you been drinking, Rich? They removed wrenched. Sorry, Robert X, there's no wrenches here.
Wrong word.
That's it. No, you can't get spanned now. Rich is okay. He said spanned, so he's safe. You're gonna get a breathalyzer test before you get your spanner, Rich.
There's a nude Aussie globe head in there too.
Where? I didn't see an Aussie globe head.
No, he's definitely nude.
So what's happened to all the spanners then? Did you take everybody's spanner away or something?
Yeah.
It was I'll control delete.
Yeah. No. I said, what happens when you press this in where the moderator thing was? Oh, that took everyone's spanner away. Oh, now I know that.
It was.
I wrote spanner, please. I asked nicely.
Did you? How far back?
And
somebody's got a cough. You wanted some medicine for that, Quasar?
I'm just above Robert X with a smiley face, a tongue poking out.
Gently's channel, I like running around naked. I feel right at home.
Jeez, and poor Spooky's saying now, why am I unspent? Look, one at a time, fellas. Jesus. Look, people keep posting. People keep posting and I can't catch up. It keeps moving on me. Right, you're out of the road. Who's next? Up the list. I'm going up the list here. Better put Golfer on the spanner list. We can't have a spooky bed here running around without a spanner.
Even a gravity's got no spanner. What's that about?
I know. Elmo's got no tool. No, I think I've got.
Gravity, asking Rich to bring you a strawberry is going to be a bad idea. He was on trying to get Rosie to come and visit him in bloody Darwin last night.
Yeah, Terry, I just wrote the last thing.
No, you didn't.
Yes, I did. In fact,
Somebody ruined it. Quasar.
What?
You'll lose your spanner.
For why?
Because I'm trying to do it, and every time you just post something, it moves on me.
I'm just following the theme.
Oh, you're following a theme, eh?
I got it. Thank you, Terry. I got my spanner.
You got your spanner. Okay.
Yes, but thank you.
It's not a 10 mil, so you won't lose it.
Okay.
That's the average. I'm above average.
You've got the 11 mil, that size that no one uses.
Farmer's boy, you can come in if you want. If you
I'm
go
special.
over to Discord and get the link.
Okay, tell him I'm waiting for him. And
there was a couple of other people in the side chat too. I seen that could have come on if they wanted. But they have to go to Discord to get it, or we have to DM a link. Sean Smith, Spanner Police. You can come in, Sean. You know where to go.
Does it have to be released 1,609 meters before?
All right, back to that's what we were doing. Yeah.
No, he's about to get to an equation for how you can calculate the time that it takes to fall.
Oh, okay.
We had a spanner intermission.
Are you saying somebody threw a wrench in the works?
Oh, he said it. He said it.
He said wrench.
Take his wrench away.
Take his spanner away.
What?
You said wrench.
You can't take mine away.
Oh, that's not fair.
It's not fair, is it? Yeah, I was going to say. Okay.
Can I call mine a shifter?
No.
Ooh.
What about a pipe wrench?
You're introducing a variable there.
You can call it a Stilson.
For those big jobs.
Okay.
Y is Y0 plus V0t plus 1/2 AT squared. And because it was launched horizontally, the initial velocity was 0, so that ends up being 0. And the way we've set this problem up here, the initial position is 0 also. So we just have this equation, y is 1/2 AT squared. And we can solve this for t. T ends up, when we do the math, ends up being the square root of 2y over a. And that's the square root of 2 times 1,609 meters divided by the acceleration of 9.8 meters per second squared. And I put all those numbers into my calculator, multiply, divide, take the square root, and I get a time of 18 seconds. So that's how long it takes the bomb to fall. That means we need to release the bomb 18 seconds before the plane is directly over the target. So, and that will determine the horizontal distance before the target. So I figure out that distance using the horizontal motion. So horizontally, this is what I know. The acceleration is 0 horizontally, and the initial velocity we calculated was 134 meters per second. And now I also know the time is 18 seconds. And you can just say this, x is vt. Remember that equation just came from this. X is x0 plus v0t plus 1/2 at squared, where the acceleration is 0 and the initial position is 0. So we just have distance is velocity times time. And if you recognize that, you don't have to write out that step. You can just go straight to this, x equals vt. And that's 134 meters per second times a time of 18 seconds. That gives us 2,400 meters. So the bomb has to be released when the plane is still 2,400 meters away from the point directly over the target.
Wow.
And that's a substantial distance. That's about 1.5 miles. If you didn't take that into account, you would miss your target by 1.5 miles. In the real world, bombers have to account not only for the motion of the plane, but also for air resistance. And air resistance really does matter at speeds like this. So in the real world, the problem is actually more complicated. But this does illustrate an important point, an important concept of projectile motion.
Now you see, Terry, on the flat Earth, you don't have to worry about all that. All you have to do is do a calculation according to the relative density, disequilibrium, perspective, ether band, and you're right.
So I just got to replace each of those values in the equation with the value for ether, value for perspective.
Yeah,
value,
don't forget the
relative densities perspective.
Disequilibrium.
Okay.
No, all you have to do is hit yourself with a flat level plank.
Oh, I needed a good laugh. Thank you very much. Of course, you've got to allow for the fractal barotropic shoaling as well. Or actually, you've got to allow for the angle of optical confusion causing dirty foreshortening of the opaque water deck with fractal barotropic shoaling and opacity within the non-uniform density transition zone, leading to collimation of the Fresnel zone and atmospheric vanishing point perspective.
Oh,
yeah,
I see you've studied that.
That's good. Yeah.
Oh, did you actually read the book that they put out? Did you?
Guess who takes and keeps notes?
You need detoxing.
Well, unfortunately, I have this handy little app called Evernote, and I do use it for keeping notes of things. And I do have a page devoted entirely to the flat Earth, and rather unfortunately, I have another one devoted entirely to Anthony David Riley. Just so that whenever anybody forgets just how incredibly stupid he is, I can say, "Remember this."
Well, we never went through Riley's paper far enough to even see if there was any other new laws or things that he's wrote out that's for the flat Earth.
I have read through it all, and it is extremely painful. It's badly written. If you just gloss over the abysmal spelling, grammar, punctuation, and everything else, it's the first 2 or 3 pages are him completely misunderstanding what those 2 clauses were about and partisan politics, and then he just repeats all the usual old bullshit. And that's it. And you can't call it a thesis. I wouldn't even call it an essay.
No, the rest of it.
If you printed it out, it would need perforations for it to be useful.
Yeah, and the rest of it's just a denial of the past 500 years of science.
Exactly. Yeah.
Yes.
But it's those little touches, like when he quotes YouTube videos. They're his fucking YouTube videos.
Yeah, quote your own videos. That's good.
And at the end, one of the references is to a YouTube video that no longer exists. That really is just the final polish of the turd, I'm afraid.
Well, the egg experiment was valid because he was wearing a white coat.
Well, yeah, but as many people said, that could have been a butcher's smock,
Well, he did butchered the science.
He did butcher it.
Well, but as he says, where is? Hang on, I've got so many quotes here. He said something about the quanta because he didn't actually measure the density, did he? Because he didn't use a God, it must be Saturday afternoon. What's the thing we use for measuring density of fluids? Was it a hydrometer? He didn't even use that, and he said something about the quanta isn't important.
Yeah, but a long time ago, Riley said we don't use logic and reasoning to determine the shape of the Earth. I mean, the same thing applies here, basically.
The quote was, "Logic and reason has never, ever, ever proved anything." I kept that one.
Yeah, that's a later one than the one I just said.
Oh, here we are. I don't have to measure it. The quanta does not have to be demonstrated. See, he uses words like that to make himself sound clever.
What was that again? Repeat this quote.
I don't have to measure it. The quanta does not have to be demonstrated.
What's quanta?
Amount.
It's quantized.
Yes, he's the sort of guy. In one comment, he didn't say position. He said locus. I mean, what a twat.
Is he trying to pretend that he knows words?
Well, he does say that words and their meanings are very important. But he
was on his show the other day doing word stuff. I should have watched the rest of that. I had a quick look at it, and he had in his background he had words and going through their meanings, and I think, geez.
Well, that's what he does. You know, anything at all. He will Google a word straight away, and he will search for the definition that best suits him.
Yeah.
And you know, leave out anything else that goes against his narrative, because of course cherry picking.
But words have usages. It could be a pronoun, it could be a noun, it could be in a verb, it could be used in any context like that.
I'm not convinced he knows what they mean.
Oh, sorry.
I'm really not convinced that he knows what a verb or an adverb or an adjective are. I don't know. He must have studied something at school to have got the relevant qualifications to go on and do what he claims to have done. I mean, we know it wasn't maths, it wasn't physics, it wasn't biology, probably not chemistry. So that only leaves you, you know, the two Englishes. I don't know whether he did geography and history. I mean,
but surely there's people out there that actually know him because of his location of where he lives. That's come across him. I'm not trying to dox him or anything, but there must have been some hint of where he grew up and what he learnt or whatever.
Well, he revealed a little bit of that in his that epic 3-hour conversation with BM Verbal, wasn't it?
Yeah, but that wasn't really a very good interview because Verbal asked him a question to say, okay, where did you go to school or something similar to that, for example. And he said, yes, I went to school, but gravity doesn't work and there's active perspective, and then he goes straight into the flat Earth stuff. And he just kept rambling on about that all the time. So Verbal wasn't really getting any just normal chit-chat from him.
I don't think that the school system that he went through was drastically different to mine. I mean, I'm about 10 years older than him. So obviously, you know, he sat GCSEs, I sat O levels. But I think the whole system still worked. When you get to a certain age, I think when you're like 14 and you've got 2 years of school left, you have to do the options, and you can drop certain lessons and keep certain lessons. Now, I know it's changed a little bit.
What year are we talking about here?
Well, I left school in 86, so he would have left school in about 96, 95, 96, something like that. Because I think he's about 10 years younger than me. So he would still, and I'm thinking of what my stepsons went through. No, they're half his age, but I don't think the school system changed that much. You know, you can drop certain lessons, but you have to maintain a core group of lessons. You can't drop maths. You can't drop. I mean, I had English language and English literature, and you could drop one of them. I think I did both in the end. You know, I think you have to do a science, and I think they do a combined science these days.
They do. You do have to do a science, and they do a combined science, because that's what Rosie had to do.
Yeah, I think that's what my lads did. I think they did a combined science because they were never really that interested in the sciences. But
Rosie was much more. The humanities.
You had the 3 separate ones, and I think in the end I dropped biology, so I kept chemistry and physics. And ironically, I failed physics and went on to become a design engineer. So I don't know how that worked.
Yeah.
Are we talking about a school system that's just government based, like it's the standard system all over Britain?
It's the British state education system. Yeah.
Right.
Whatever you want to call
it. Different areas use different examining boards, so the exams are not everybody who takes O-level physics takes the same exam, but they are all set up so that the standard of testing is consistent across the country.
Yeah.
So that and is statistically valid in that manner across the country. And I did I did English, maths, chemistry, physics, metalwork, and technical drawing, I think, as my O levels.
That was the only A grade O level I got, technical drawing.
Do you want to know the really funny thing? I got a grade C technical drawing. I failed the CSE equivalent because back then we had O levels and CSEs, didn't we?
Yes.
And the CSE was if you got top marks in the CSE, it was equivalent to a grade C O level.
Yeah. The
O level was engineering drawing. The CSE was pretty much all geometrical constructions, which is which was the bit I found hard.
Yeah. Yeah, we had some of our exams were what they called a 16 plus, and it turned out to be sort of the prototype of the GCSE.
Right.
You sat it, and if you got a good enough mark, they gave you an O level, and if it wasn't quite good enough, they gave you a CSE. And that because we couldn't quite understand it, and they said, "Oh no, it's like the prototype of a new exam system." And within a year or two, O levels and CSEs were scrapped, and they called it the GCSE. So
that's
just
for the viewers out there. What does GCSE stand for?
GCSE
of secondary education.
Secondary education.
G and the G.
The G is just the general, I think. I think it's just a
general certificate of secondary education, GCSE.
Okay. Yeah.
Yeah, because back in the old days, the lowest qualification you could get was a CSE. Then what most people went for and got was the O level. And then when you were 16 and sort of basically finished your school,
done your O levels,
you could stay on and do A levels. And they were sort of like the bridge between O levels and going on to university. So you did your A levels, and then you'd go to university.
Are your O levels like owls in Harry Potter?
Unfortunately not, no.
When I came to Australia from England, I came here when I was 15, and I had to resit a year here in Australia. So I went from third year high school, then the next year was fourth year, then the next year after it was college. So it was all completely asked about face coming from Australia, from England to Australia. There was no 16 exam. There was an exam at 18 when you left college.
Lenny said CSE was for Dumbos, GSCE was for O level, and A level was for uni access.
Yeah.
Yep.
Yeah, I never did A levels. I couldn't wait to get out of school. I hated it because I kept treating us like children. And I said that to one of my teachers one day. She just, well, you clearly don't enjoy school. And I said, well, no, because you keep treating us like children. She said, you are children. I said, oh, yeah, sorry, I forgot.
But when I came to Australia,
my parents used to joke that I was born middle-aged.
In England, you had to call the teachers Miss by their last name or Mr. by their last name. But when I came to Australia, it was all first names.
Oh,
really?
Yeah, it was a complete turnaround. Yeah.
Oh no, it was all surnames. It was all.
Yeah, it was all surnames when I went to high school.
Yeah.
Oh no, we could call our teachers by their first names.
The one change we had in New South Wales was back in the 70s when I left high school. I left in year 10. So that's 10 years of schooling all total.
Yeah.
And then you could do a year 11 and a year 12, was your higher school. And they ended up changed. That got changed a few years later.
No, that changed. That would have changed when you were in fourth year, wouldn't it?
Fourth form.
Yeah,
fourth class or fourth year 10 is fourth form.
Yeah, fourth form.
That did get changed when I went to high school. I went to those numbers 7, 8, 9, 10.
Because it was third form when I went into year 10. It's completely confusing.
Yeah. But now they've got it. I don't know what year it was. I know it was only up until sort of recently, where you couldn't go to you couldn't leave school at year 10. Now you have to. If you left at year 10, you had to either have a job or some sort of training or university, or not university. I'd say TAFE or something. But you have to stay on to year 11 and 12, basically. Back then, you could just leave at year 10 and get a certificate.
Yeah, that's what they did here. I'm trying to think how many years ago it was. Maybe 4 or 5 years ago. I think they've changed it now. At 16, you can only leave school if you're going to do an apprenticeship.
Yeah,
you can't just leave. You can't just leave school and get a job at 16 anymore.
It's like
you have to have compulsory training to 18.
Yes, there has to be some sort of training, be it an apprenticeship, a recognised apprenticeship, or you stay on and do your A levels, or you go to any sort of further education. But you can't just walk out when you're 16 and go and get a job and sweep the streets or dig holes or whatever. You've got to have something.
Or go down the beach and bum on the beach every day.
Well, you can do that, but I'm pretty certain that the government won't actually give you any money for it.
No, they wouldn't.
I don't think you're even allowed to sign on.
You can't claim unemployment benefit. You have to be in.
Yeah.
Because that was one of the things that kind of went back in '95 when I was doing my adult ed teachers training. That was one of the things that pissed me off with one of the jobs I got. Is in adult ed, the students are supposed to be there because they want to be there.
Yep.
But I got to teach the group of kids that were at college and doing the only subject they could get into because they weren't really interested in being in education.
Yeah.
That was really hard because it was literally like having it was literally like teaching in secondary school with the attitude, because it's like we're half of the kids in that group were there for one reason and one reason alone. If they weren't, they didn't get any money at all off the government.
Yep.
And by that time, there were fuck all jobs in Lowestoft left.
Yep.
Because Brook Marine had closed, so there was no boatyard to go and work in, and offshore was in a bit of a down, and so there was. Well, let's just say there was no work in offshore for people who didn't have any qualifications.
Yeah.
I grew up in a small country. I grew up in a small country farming town, and it was pretty standard when I went through school for most of the blokes most of the boys to go through to year 10 at least, and then stay home and work on the farm. And then it became that they would leave at the end of year 11. But even now, they have to stay to the end of year 12. Otherwise, they can't even work on the farm properly because the farming is such high technology now.
Yeah, you got to put in before you can pull out.
we did have one boy leave at the end of year 8 to go and be a lathe operator at his father's sheet metal working business. And I spoke to him the other day, and this is the way you end up when you do that. He tried to explain to me the other day that evaporative air conditioners work more efficiently if you put hot water in them because it takes less energy to evaporate the hot water. Yeah, that's what you end up saying when you leave school at the end of year 8 instead of going through 4 more years of school.
So that's where all the flat earthers come from.
Yeah.
What?
Hot water. Right. Okay.
Yeah.
What?
That's a new one on me. I've not heard that one before.
Yeah.
I mean, I'm not an expert on air conditioning. I can design these systems. I don't install them, but I'm fairly certain you don't kick them off with hot water.
No, that's right.
Oh dear. Bless. Oh well, you learn something new every day. Problem is, you have to forget it again because it's bollocks.
well, we'll just watch the same video then every day then.
Well, that's what's got me with the flat Earth. Now that I've sort of had to sort of take time out of it because I'm like working and stuff, and you sort of come back to it, or just sort of watch the comments in the afternoon because it's a job to listen to it in the office. But I can look at the comments and it's just like, well, this is just the same old tired old shit going round and round and round and round, and it's like, guys, it's not flat. Go over it. Go out there and do something useful, you know.
No, we've already done the merry-go-round experiment, so we went around enough.
And if I hear somebody say Coriolis one more time,
oh shit! I hope this one hasn't got it. Well, what my oh shit! I can't remember words sometimes. Sorry.
Sorry.
I'm trying to get to it in the basic levels. Trying to like even some of these ones that we've watched already, even though it had some formulas and that in it, but it had a couple of drawings and stuff. But a couple of other videos we watched had some explanations and some examples of how frame of reference is working, and I'm trying to just show stuff that brings things back to their basic forms, because a lot of the conversations I hear, you'll have the flat earther say something and then you'll have somebody dispute what they say, but sometimes it goes over the flat earther's head for whatever reason. It goes over their head because of the individual flat earther or type person's attitude towards what's been told. But if the explanation is a little bit too advanced in general, I can't see any reason why they wouldn't object, because it's like you're talking over them, and I don't feel that like we should be talking over them. We need to be not talking at their level, but just bring things back to the basics to find out what they do understand, and then bring it back to that level.
What, so Terry, you're trying to say that we can't use Ricci tensors and Einstein field equations and stuff like that?
Well, we've got to explain what they are.
I don't think you can use words of more than 4 syllables, to be honest.
One thing that's
when you lose them.
One thing I've found is they don't understand scale.
Oh yes.
Well, we might cover that next week then.
Yeah. Like someone wanted to explain the Cavendish experiment to Ross, flat earth Ozzie Jesus, and he just convoluted and obfuscated and convoluted, and it was just, in the end, it was just so confusing.
Well, I mean, that's quite a misunderstanding. That, I mean, that's something. I hate to keep bringing them up, but that's something Riley keeps doing. This 1 in 50 million. He keeps getting that wrong. Yeah, and he keeps reading from the very document where Cavendish is explaining. Look, this is really fucking difficult to do. It's really sensitive. It's this sensitive.
Mm-hmm.
And he keeps getting it wrong. And I think too many people hear this, and if they don't understand it themselves and they hear somebody else explaining it, they go, oh yeah, that makes sense. And that's it. End of story. They've heard somebody explaining it, albeit wrong, and just accept it as the gospel.
I mean, any normal person that reads that paragraph in that report would realise that what he's talking about is that the gravitational attraction between the small and the large lead balls is about 1/50 millionth of the gravitational attraction between the small lead ball and the Earth. That's plainly obvious in the document, and yet Riley misinterprets it every time.
Yeah, yeah, I know, and I've tried telling him that. I don't know how many people have tried telling him that, and in one ear and out the other.
Well, I actually did a calculation for him and showed him that the calculation matched the 1 in 50 million. But no, that didn't matter.
That's because you can't trust maths.
Yeah.
But they don't trust maths because they can't do maths.
Well, you can't trust Riley's maths with 5 divided by 0.
Even 1 in 50 million is still a result.
Yeah.
Yeah.
I mean, basically, the guy was saying, look, this is a really difficult, really sensitive thing to do. You've got to be really careful. And it's all, the measurements are very, very small, and there's so many possible influences that could affect it. And yeah, it might be difficult, but it doesn't mean it's impossible.
I mean, we do experiments that are much harder than the Cavendish experiment today.
Oh yeah. But as soon as you say maths, they'll just switch off, and I think it's because they don't understand it. It's like magic or the dark arts or something, I mean, I'm the same when it comes to electricity. I can design systems that have water in them or air in them, but don't expect me to start doing electrics, because that is the dark arts. I've never been able to understand sizing wires and everything else. I mean, pipework, ductwork, piece of piss. Anything with electricity in it? No, I'll leave that to the experts. That's magic.
But farmers, electricity mostly is about piping and ductwork.
Yeah.
How do you think we move the electricity? How do you think we move the electricity around? We use things called wires, which are pipes, and in fact, when it comes to doing the radar, we even use stuff called waveguides, which is literally ducting for radio waves.
That's just maybe, but I just can't. I've never been able to get my head around it, so that's why I'm a mechanical engineer and not an electrical engineer.
Alan, are you telling me that those wires carry electricity? I always thought it was grey and black smoke, and when the wires broke, the smoke came out.
Well, yeah, that is how electricity works. Didn't you realise electricity was blue? Was like mostly a blue-grey smoke.
Yeah, and the cost of the repair is proportional to the density of the smoke that's released.
I've tried. I've tried so many times to try and smoke back in. Never works.
Oh dear.
I like actually working with stuff I can see. Electricity.
Yeah, it's a strange thing there. You can't really see it.
I have to admit that I do prefer older electricity stuff where you can actually see all the individual components with the naked eye.
Yes. Not anymore. It's all microelectronics and computer this and
and one of the quickest ways to check a circuit to see if it's operating correctly or not is to go around and touch all of the active components, because very often when they stop working they get cold, because that's what happens with valves when they stop working. They generally get cold.
Valves, bloody hell!
I tell you what, it makes for really quick fault finding, because you just have a quick scan around to find out if anything that should be hot isn't hot. And there you go.
Yeah,
change that first.
Yeah.
If you're touching it with your bare hand, aren't you worried about current jumping to you?
Not when I'm on the side of the rack with the valve sticking out, because all the wiring is the other side of a big earthed metal plate. It ain't going to get out and get me. And the valves are all in evacuated glass envelopes, and inside, and held in place with metal cans usually, and you just touch the top end of the metal can with the back of your fingers very carefully, and you get to find out whether they're warm or not.
Yeah, that's part of the method anyway, Terry. Part of the method anyway, Terry. If you touch something and it should have killed you and it didn't, then it's not working.
Okay.
Yeah, there is that one.
Yeah.
There was some conversation about health and safety and taking shortcuts the other day, and I did on one occasion stick my hand in the back of the control panel on the live side of it, because instead of walking around the 5-bay rack to operate the reset switch like I was supposed to, I opened the door on both sides because the racks were only about 9 inches deep. And I stuck my hand through the 2U wide gap underneath the control panel to reach up and grab the switch on the front and pull it down. Like I said, I managed to stick my hand between the two panels, and I treated that as a learning experience. It was a bit unpleasant because we're talking about power supply, because I stuck my hand on the back of the fuse holders, and we're talking like plus and minus 300 volts, minus 600 volts, all at like half to an amp and a half current ratings.
That's enough to fry you.
That's a classic Douglas Adams quote. That is, a learning experience is one of those things that says, you know, that thing you just did, don't do that.
Don't. Yeah. My worst learning experience was make sure that all the HT leads on your car have insulators on them, especially when the end of it is attached to something you might need to adjust while the engine is running.
Yes, they can give you quite a good zap.
Though I wouldn't go around touching red wires.
Yeah, because touching the coil lead where it goes into the distributor while the engine is running is a bad thing.
Oh, I've seen someone do that while they were holding onto the bonnet.
It can hurt a bit.
Fortunately, I grabbed the distributor with my right hand and was grounded to the car through my right hip, leaning on the front wing. So I didn't put it across my heart. And because it was pulsed, I couldn't bloody let go of it.
Yes.
It seemed like I was stuck on there forever. And there's me, and you can feel the engine kind of struggling to run. I go, stall you bastard, stall you bastard, stall you bastard. But it was very good at stalling. If you didn't, that was why I was adjusting the timing. Would the bloody thing stall when I had hold of it? No. Yeah, I eventually managed to pull my hand off and sort of stagger away, and fuck, did I feel ill after that one.
Yeah, I bet.
Well, I do have another video that we're going to go through, but this one takes 27 minutes, so I think that's going to fill up.
11:30. You got 27 minutes to go.
Yeah, that's going to take up a fair bit of time. I don't know if we got anything shorter. You got something that's a bit short there, Secretary?
Don't everyone laugh at all at the same time.
What? What? I didn't say anything.
It's okay. No, I didn't go there.
He's always got something short hanging around.
It's just making it worse now.
What?
What, Mr. Innocent?
What? Terry.
Now we know Peter's secret.
Terry, that's a bit below the belt.
Someone get his coat for him. Yeah. Is this your coat, mate? Yeah. Oh dear. Yes. Oh, yeah. I suppose Jose's on in what, half an hour or so, isn't he?
Yeah, I haven't got a notification for it yet. No, I haven't.
I did get a notification. Yeah, he's on it. 3 o'clock night time.
You got one, but I didn't. Oh, I see we are. What's this one? No, he was live.
Number 173 is going live in just over 34 minutes' time.
Okay.
Oh God, and Ali B's in there already, for fuck's sake. So it was, I posted first, then it was RT96 GPS, and Ali B's come back. You three suck a lot. That guy. He does my crusting, Ali B, because he's as fucking gormless as the rest of them.
There you go, Terry. That one's 2 minutes long. Gravity said I had to wait till the end of the night, but it's a little bit early. But so that's the Einstein theory one.
Oh. So we're jumping
Okay,
we're jumping across to it to get a taste of what's to come.
Well, it's only 2 minutes, and it's only really just a taste of it. It's
Oh, okay. Because we're still going to be looking at the what's it called again? The first one we're talking about? Not the Einstein.
Galilean.
I've got to remember Galilean with the ship. Okay. And Finding Nemo. Right, okay. I remember all that.
What?
What's Nemo got to do with
it? Wasn't Galilean in the ship and Nemo was looking at something bouncing, dropping in the ship as he went past?
No, Nemo came after.
I don't know. I've never watched Finding Nemo.
Nemo got lost in Sydney Harbour.
Wait a minute. Wasn't there a graphic representation of Galileo in a boat dropping a ball as the boat was sailing past a fish? And the fish's from the fish's frame of reference for the ball dropping.
Okay. Yeah.
Right. See, and you reckon I'm slow. Oh dear.
No one said that.
I said Galilean with the boat and Finding Nemo thing, whatever. Yeah, because the fish.
You named the fish, bud.
Okay, so.
Are you actually Ted Rogers? And this is 3, 2, 1.
Who's he?
Oh no, you have to watch it to understand when they give these supposed clues, and then he explains them at the end what these clues actually meant, and it's like, how the fuck did you get that? Made absolutely no sense whatsoever. What a bizarre program that was.
I try to be serious.
Well, it's a thought that counts, I suppose.
Yeah.
Don't be serious, be Terry.
Okay. Seriously.
Come on.
Okay, we'll watch 2 minutes and 3 seconds of something. Simultaneity. Albert Einstein. No, it says simultaneity. Albert Einstein and the theory of relativity. I can read, you know. Here we go. Oh, wait a minute, we forgot something. I know what I forgot, don't tell me.
Okay.
Don't tell me. All good.
Imagine two observers, one seated in the center of a speeding train car, and another standing on the platform as the train races by. As the center of the car passes the observer on the platform, he sees two bolts of lightning strike the car, one on the front and one on the rear. The flashes of light from each strike reach him at the same time, so he concludes that the bolts were simultaneous, since he knows that the light from both strikes traveled the same distance to his eyes at the same speed, the speed of light. He also predicts that his friend on the train will notice the front strike before the rear strike, because from his perspective on the platform, the train is moving to meet the flash at the front and moving away from the flash at the rear. But what does the passenger see? As her friend on the platform predicted, the passenger does notice the flash from the front before the flash from the rear, but her conclusion is very different. As Einstein showed, the speed of the flashes as measured in the reference frame of the train must also be the speed of light. So, because each light pulse travels the same distance from each end of the train to the passenger, she can only conclude one thing. If she sees the front strike first, it actually happened first. Whose interpretation is correct? The observer on the platform, who claims that the strikes happened simultaneously, or the observer on the train, who claims that the front strike happened before the rear strike? Einstein tells us that both are correct, within their own frame of reference. This is a fundamental result of special relativity. From different reference frames, there can never be agreement on the simultaneity of events.
Sagnac.
We're going to have to investigate that one a little bit further then. But I thought
gravity's still not a
was mentioning the frame of reference as well. But Einstein says it in a different way about the frame of reference. Yeah.
I don't know. Maybe I'm just too sober for all this.
Well, that's always an option. All right.
I'm gonna have to do it. It'll come up in my search now for recommended for videos like this. So I'm gonna have to do a little bit more when I get time to watch a few more basic ones.
Did you see one of Riley's videos being blocked for copyright? This,
yep. Yes, but it was at the start where he's got what's that artist's name? Bob Ross.
Yeah.
Yeah.
And he's just taken a whole chunk of that. There's him, there's the music and everything, and I think apparently it's the YouTube AI that sort of picked it up. Rather than anybody making a specific claim, I think it's one of these automatic things that is sort of picked up. That.
But if Riley put something in, then the other mob can claim copyright. They own the copyright. If he tries to get it released, like unblocked, because then it'll go to the copyright holder to the copyright holder will be notified then.
Yes.
It just seems to be a coincidence.
It's blocked. It's blocked in 178 countries, I think.
Just seems to be
really
coincidence. There's been a few people had a few copyrights this week just for basic things.
Yeah,
even John got something for some music that he played. I got something for a video that I was playing.
Yeah, Slice Bar Kane did a thing about it last night.
Yeah.
But yeah, he seems to think that it's all part of the YouTube algorithms have sort of picked it up, rather than whatever the
company.
I can't think the company that owns the rights to it. I don't think they've made the complaint. I think it's just something that YouTube does.
So you think YouTube might have been fiddling with their rules and regulations in their algorithm, and it's starting to pick up things that a bit more sensitive or something, or
possibly, yeah. I mean that's because that's what it does. You know, their systems are getting sort of more and more advanced, and I guess it spotted this, and it's just he's copied that whole chunk verbatim without doing anything to it, and yeah, I guess he'll get a warning.
Yeah, well, mine was weird. We went offline for about 5 minutes, and then we came back online, and I checked my channel, and I didn't get any strikes or any infringement or anything. They just retracted it by the look of it. And I just edited.
Strange.
I edited the video and I reposted it back up. So everything should be fine.
I just posted something from Flat Earth about the Sagnac experiment. Have a read of it. That's for later.
Oh, okay.
Oh, the Flat Earth Society. Oh, that would be a good read then.
Well, have a read of it, because they're saying that Einstein got demolished and proves the ether.
Oh God, not again.
Yeah, have a read of it.
I was like listening to Glee.
I'll put in homework.
Yeah.
Yeah, I'll yeah. I've got it on the tab now.
It's in homework for you to go back through. Anything in homework, Farmer, is stuff that we'll either touch on for our videos, or if anyone goes through it, they can summarise it and we can talk about it next stream.
Well, it explains like from different frames of reference. If you looked outside looking in, you'd swear that the speed of light is slowing down. But if you're actually in the experiment, the speed of light remains the same. Different frames of reference, like the video we just saw.
Mm-hmm. Okay.
Which one's correct?
Depending on your frame of reference.
Yeah, but have a read of that first. It might take a little bit more.
Not Malcolm Bowden.
Yeah.
I remember Malcolm Bowden, the fucking pellet, from watching CHL's Geocentrism series.
Oh yes.
Which was part of the way I found myself into the whole fucking flat Earth shit. Because I kind of discovered a little bit of the crazy young Earth creationists, and that kind of bumped me in the direction of Coolard Logic's videos. And I watched his geocentrism one, and then it kind of pushed me in the direction of flerfdom.
I can't remember whose I saw first. I'm fairly certain I found out about the flat Earth. I was watching something else on YouTube, and there was a link to the Non Sequitur show, and I watched a couple of them, and there was something on that can't for the life of me remember which one it was, but there's something about a flat earther. So I started looking at that, and it was like, come on, people don't actually think this in this day and age. And of course, down the rabbit hole I went of finding all of these idiots, who love to pretend that the Earth is flat. Yeah, because that's what they've got to be doing. They've got to be pretending, because 10 minutes of simple analysis. Just go out and watch a fucking sunset. The Earth isn't flat.
Well, about 2 years ago, we were in TeamSpeak. There was about 80 people in the channel, and one person came in and said, "Have a guess what? That's flat." Right there. 79 people just went, "What?
What? No, it's not."
What? Really?
We've got photos and everything. Come on.
And that's how I've discovered all this flat Earth crap polar.
Yeah, it is fascinating from a psychological point of view to sort of watch, how to be a flat earther, the things you've got to reject, the whole sort of, gravity isn't real, the planet doesn't move, space obviously can't be real, because as soon as space and space flight is real, you have to accept everything you see from space.
And you've got to reject you've got to reject all experimental evidence that proves otherwise.
Yep, you're basically rejecting reality. So you're either incredibly thick, and I have met people who are thick enough to think that sort of thing, I'm afraid, or they're deliberately doing it for God knows what reason, or they're just pretending for the same thing. They're so they can feel to be part of this society of people who are woke.
Yeah, it's like I watched a video of Riley's earlier this evening. That's the one about, prove Earth's rotation. You can't provide any evidence for Earth's rotation. And there's one particular guy in the comment section. He says, hang on, I've provided you with all these references that show that the Earth's rotating, all these evidences, and I've listed them and put links to them, etc. And basically Riley's just ignoring them all. He just turns a blind eye to it and just keeps on saying that you've got no evidence.
I will quote the man again. I've seen the evidence and I reject it.
Yeah. I reject your evidence and substitute my own.
Yeah. Yeah, I mean, because this was an argument I had with him. He said, what's your single most basic evidence that the Earth is moving? And I said, sunrise. Go and watch a sunrise and a sunset. And if you can, watch it through a solar filter. the sun doesn't change in size, which means it's not the sun that's moving. Because if the sun was moving, it would change in size. It's not changing in size, ergo, we are moving. And that's it. That's all you need to do. You don't need to do independent, dependent variable experimentations and complicated mathematics or anything like that. Just go and watch the fucking sun. And that's why they say, oh, you can't prove the shape of the Earth by looking up at the sky, because you can.
Absolutely.
You have to reject reality. It's just, I almost feel sorry for them, but most of them are doing it on purpose. They know what they're doing. So I can't actually feel sorry for them. There are a few out there who are just too dumb to know what's going on and just, see a well-presented YouTube video and think, oh, well, that must be true.
Or you've got people like Arwen who just make up their own shit and believe it.
Oh,
he's in a different category from the rest of the flurfers, really.
Yeah, there's a guy who needs help.
Yeah,
actual proper help. Him and
Pete Shea.
Yeah. He's got issues.
I think you've got to include Flat Earth Ozzie Jesus in that category too.
Trying to have a discussion with him today. I was listening in on that one.
After this morning, he's.
I tried to be so polite, but sorry, Alan.
I was going to say he is completely like all the rest of them now. It was just like talking to Spurs Gizmo.
Oh.
He would overtalk you, not let you finish a question. When you tried to tell him something, he would question it in such a way to move the goalposts to the point where it was obvious he was being a complete and utter lying. Insert expletives of choice.
There's a guy who's just a waste of oxygen. One of these after shows a couple of days ago where you just kicked him out, and it was like, finally, why didn't you do that? Why did you even let him in? Because he's just there to argue. He has nothing. He's got nothing to present. He's got no case to make. He is an attention whore, and that's it.
Old skid mark.
Yeah.
Yeah.
He's
the problem was
a waste of space.
Now this is the difficult problem. If we want them to come and talk to us, we've got to at least not. We've got to at least let them have. We've got to give them somewhere they can come and talk, and not block and ban and kick and mute them. But on the other hand, they still need to understand that they can't just have the floor and spout whatever they want to spout and not get questioned on it.
No.
And after I kicked Spurs for that, and I because the day before he'd come on twice and he rage quit twice.
Yes.
When it was like, no more conversation until you bring a positive claim. And they just, and he just couldn't bring any positive claim at all. And he quit. Yeah. And then I actually said in the text to him, if I let you on, you're coming on with a positive claim. You're not just going to come on and do what you normally do. And he came on and did what he normally did. So yeah, I booted him. And I didn't wait very long, but that would, I was.
Yeah, he's. He never brings anything. He never, ever has an answer to anything. And what did he say the other day? Oh, I've been doing this for 6 or 7 years. Yeah, and in those 6 or 7 years, you've bought nothing. Absolutely nothing. He just comes in and he knows how to play people, particularly people like Rumpus. Rumpus just can't resist it. He can't help himself.
Yeah.
you actually, your best bet is just ignore him.
Well, when
Like
he
we
came,
did.
I let him in on my stream there. I think it was last week, and it was like flies on a pile of shit. And I was the fly on the outside trying to get in, and I couldn't get in.
Look, it can be quite fun arguing against the flat earthers, like even the ones that pretend to be flat earthers. It can be entertaining arguing against them. There seems to be a bit of a backlash at the moment going on against people who do engage and argue against the flat earthers. There's a bit of banter going around that it's unhealthy for people to do that. But I'd defend that. It can be entertaining and fun arguing with the flat earthers. But not to the point where you actually start to really, start behaving like rumpus, where you come in and you start calling them all more utter morons and idiots and stuff like that. That just gets obnoxious. That doesn't really make for a good conversation, really, does it? And even though they're going to spout bullshit, and that they're going to spout, the same old thing over and over and move the goalposts and, deny evidence and stuff like that, you can still let them have their say and then argue your point against them and have a reasonably entertaining conversation. But it's just bad behaviour when you come in, even though you're right, and you interrupt them and you call them morons and idiots and stuff like that. It doesn't sound nice.
Well, as soon as you get them on the defensive, they're going to put their guard up and start to be all, what are you attacking me for? Take it personal.
Well, yeah, I think even if they really believed what they were saying, is calling them an utter moron and an idiot going to enhance your chances of convincing them? Probably not.
No, I don't think it will.
No,
but you won't. All of these faces who turn up again and again, you aren't going to convince them.
No.
It's not going to happen. Even if you got them into space, they'd just go, no, this I've been drugged.
Right.
This is CGI.
And
they're utterly convinced they're right.
Yeah, and as long as you understand that to be the case, as long as you understand that you're not going to be able to convince them, then you can have a decent, entertaining conversation with them, because that you're not going to get anywhere with them, but you can play along and, argue your points, I guess, against theirs, without being obnoxious.
I think
it is difficult though.
I think this afternoon, or Alan's this morning, with Flat Earth Aussie Jesus, I really tried just to keep that calm and level voice. I tried so desperately to. He didn't understand the big side of things or anything, so I tried to rephrase what I was saying to him in such a way that it was easier for him to possibly understand. But like Alan said, even though I was keeping somewhat of a civil tongue, I wasn't calling him names. He still, as soon as it got to a point where what I was saying made sense to him, therefore, well, possibly this is attacking my beliefs, I'm going to turn this around and get very angry at you and start bloody accusing you, over talking you, and all of that type of stuff. So I don't know. I don't know which way is the best way to do it, but
yeah, I mean, you heard me talking to him at the end there, but at no point did I call him a name or call him a moron or call him an idiot. I was just calling him out on his behaviour. It's okay to get angry at these people. It's okay to be upset, but going that step further and calling them morons and idiots is a step too far, I think. I mean, you have the flat earthers that do that, like Flat Earth Data and Right the Hand, that come in and are just obnoxious. We don't like their behaviour, and they're horrible people to talk to because they don't engage in a genuine conversation. And it's no different to a baller coming in and doing the same sort of thing. When you get people like Rumpus come in and interrupt and constantly talk over the other person and call them utter morons and idiots all the time, and it doesn't make for a good productive conversation.
No, but I some of them I struggle to keep my temper because it's just you've heard all this shit umpteen times before, and you just get to the point. I mean, every comment I make now about Mr. Riley, he is Riley the retard.
Yes.
And I will call him that because he is, and his last comment to me, why should I be polite to him? I don't know. It is difficult sometimes.
Can I just say to Sean Smith in the side chat, I'm sorry. I didn't mean to. He turned around and said, I did attack Flat Earth Aussie Jesus with logic.
You bastard.
How dare
you?
That is below the belt.
There's no call for that sort of behaviour, really. I mean, come on.
I apologise.
I mean, using logic and reason, that's low.
You can't prove anything with that.
Next, I'll be using those horrible things like numbers and calculators. Fuck.
Yeah, and I hope you didn't bring facts into it because that's really bad.
Oh yeah.
Possibly.
They don't like facts. Facts don't sit well with them, I'm afraid.
I find it very funny that like a lot of I see a lot of the bigger channels getting to that point of almost exhaustion with the whole situation, and you can see them getting worn out to the point that they are losing their cool a lot quicker. Some more than others, and I just, I'm starting to think, where's it going to go? Is it going to get to a point where the people that are trying to do that whole education of the ball earth type thing to these people, are they going to end up as angry and aggressive to each other that's the way I kind of see it going if we don't start to look for a better direction to go, if that makes sense at all.
Yeah. I guess the question that everybody has to be asking is, can Anthony Riley win DFOTY this year?
No.
He's not allowed to.
No,
he shouldn't be allowed to.
No, he's got to be second again.
Yeah, he's guaranteed.
He has to be second.
Place. Yeah.
He's
all know,
not allowed to win anything.
Well, you know who's going to win this year?
Kyle.
Kyle, hands down, has got to win this year. But anybody to win, but not Riley. Riley's got to be second. Not third, not fourth, not last. Second again. And I want him to be second every time.
Because he has to be the most successful failure at everything he does.
I was about to say there should be a perpetual award as well.
I think there could be several of them. Let's be frank about this.
And the nice thing about that is that it doesn't have to break any of the Dumbfuck of the Year award rules that we have in place already.
Yeah.
Because, once you've won it once, you can't win it again.
Yep.
You have to be a Dumbfuck by choice.
Yep.
Riley is definitely a Dumbfuck by choice.
Oh, yes.
So if he comes second every year, it's really our way of reminding him that he is the ultimate dumbfuck.
Yes, because he can never win it.
Because he never wins. Because if he wins the fact that he'll never be eligible for it again.
Yeah. You think he knows this, and that's why he's being one of them to get to be second again, just so he knows that he will be.
I don't
I
know.
don't think he's that intelligent to do that.
I mean, really, certainly over the last few months, the only thing that he's proved he's any good at is being wrong.
Yeah.
Yeah.
And he is an absolute expert at being wrong. Everything he touches, he's wrong. Which is quite impressive, I guess.
And
Because
to be paid
statistically,
for
at
it.
some point, he's got to get it right, but that hasn't happened yet, I don't think.
Well, I think we might end up leaving it here, seeing that Jose is going to be on any minute now. So,
oh yes,
for
yes, he
people
is,
to,
isn't he?
to transfer over to there or not. So thanks everyone for
Well,
joining.
can I say some? Can I say something, please?
No, sorry, I'm saying goodbye
Everybody.
to everyone. Yeah,
Before
okay,
you
Alan.
say goodbye, can I
Poor
say
old
something?
Alan.
I just wanted to remind people that we won't be doing an actual Jose after show tonight. Instead, at 6:30 British summertime, which is 17:30 Zulu or UTC or GMT or whatever you like to call it.
You could have just said PM.
Yeah, this evening.
Yeah, 6:30 this evening,
cool.
Our time. I am doing an introduction to photography.
Ooh.
And it's going to be it's going to mostly be how to use your camera, how to set stuff on your camera, what options would be what would be your best options for camera settings for various circumstances. So please come along, bring your camera.
Oh, damn. I thought you were going to supply them.
Oh. Yeah, but decent ones. None of this P900 nonsense.
Exactly.
Got the camera.
Okay.
Well, no, you can bring a P900 if you.
Right, I haven't got a P900.
I've got I've got an old toilet roll tube. Will that do?
Yeah, that's it. Not got many settings on it, though, has it?
Actually, one of the things that you can do with digital is make yourself a pinhole lens and stick it on the front of a digital camera, because they could be fun to use.
Are you going to be explaining how to use my old Polaroid Instamatic, Alan?
I am quite happy. I am quite happy to help you get the best out of your old Polaroid instant camera.
Well, I've got one better. I've got an old box camera. Would that help?
I've got a box brownie.
Yeah, I got one of them too. I got one of those with the concertina front on it.
Yes.
This one, the one I've got's actually a box.
Okay.
Yeah. You can get the box. It's
no zoom on it though.
Yeah, I know. Unfortunately, those are one of the very few cameras I've never actually, few types of camera that I've never actually used.
They're just point and click, basically, aren't they? Those ones.
They are just point and click, but I've never used the 620 type film that goes in them. You can still put film in them. A lot of them used 620 film, which is basically 120 format film on a different shaped roll holder. So what you have to do is you have to take the film on the one spindle and then transfer it onto the spindle that fits your camera. But no, that's one that we would have to leave until a slightly more advanced class. But otherwise, pretty much any camera. If you have specific questions about your camera, that is great. But please, if you can, beforehand, download the full manual, full user manual from your manufacturer's website, because I am not omniscient. I am not omniscient. I don't know every camera ever made. I'm not bad with Canon DSLRs because I have used most of those, and so roughly know the control layouts for them. Other cameras are going to be very similar because they're all doing the same job. But what I can do is help people find the information they're going to need in the manuals, because actually knowing where to look in the manual is 90% of finding the right information.
Yeah, it's half the trick.
Actually, Terry, just before you close too, maybe it's a good idea to point out to those East Coast Australians that tonight you've got to change your clocks.
Oh yes, daylight savings starts tonight.
No,
you have to push.
No,
we have to put our clocks forward 1 hour.
No, I don't.
I do.
We've got another couple of weeks, I think.
Yeah, except for the retarded people up in Queensland, you don't have to worry.
Except for them.
Tonight, 2 o'clock. 2 o'clock. You got to do daylight saving starts 2 o'clock.
Everything will do it automatically. I'm not worried.
Mine does it automatically.
I'll do it now then. Okay, it's 1 o'clock.
My bloody watch doesn't.
Wait for it.
No,
Wait
my
for
watches
it.
don't.
Doesn't it change at 2 o'clock in the morning, Terry?
Yeah,
it does.
My phone does.
I thought it changed at 1 o'clock in the morning when it was going forwards.
But the weird thing is, the one on the wall and my digital clock next to the bed, I have to change them manually. They don't seem to change automatically.
Oh dear. And the wind up alarm clock doesn't change automatically either.
Yeah, the cuckoo's broken.
Cuckoo's still asleep.
Cuckoo's out for lunch.
Nobody told him.
Cuckoo's still in the other side of the world.
Oh, dear. Oh, hello. Jose started.
Yep.
Well, actually, I just pulled out my old 20-year-old Sony CyberShot.
Yeah.
Okay, then I'll let everyone go. Thanks for dropping by. Okay.
I'll see you all later, I hope.
Yep.
Bye.
Later. Bye.
It's good night from him, and it's good night from the other bloke.
Them.
From them.
Yeah. Okay.
Good night.